Real-time operating system. A real-time operating system, RTOS, is a special kind of software used in electronic devices that need to respond to events or inputs very quickly and predictably. These devices might include robots, medical equipment, and aerospace systems. The key feature of an RTOS is its ability to process tasks quickly and efficiently. When an event or input occurs, the RTOS can immediately prioritize and execute the appropriate task, ensuring that the device responds in a timely and predictable manner. To understand this better, imagine a robot arm in a manufacturing plant. This robot arm needs to move quickly and precisely to pick up and place objects on an assembly line. An RTOS can ensure that the robot arm moves exactly when it needs to, without any delays or interruptions. An RTOS is a specialized software that helps electronic devices respond quickly and predictably to events or inputs. This is achieved through efficient task processing, prioritization, and execution, ensuring that the device operates smoothly and efficiently. Real-time kernel. A real-time kernel is a type of operating system that is designed to quickly respond to events in the environment and execute tasks in a timely and predictable manner. Think of it like a traffic cop who manages the flow of traffic in a busy intersection. The real-time kernel is constantly monitoring and prioritizing tasks to ensure that the most important ones are executed first. This is especially important in systems that require rapid response times, such as industrial control systems, medical devices, and communication networks. In these systems, even a small delay can have serious consequences. To achieve real-time performance, the kernel uses a variety of techniques such as preemptive scheduling, priority-based task management, and interrupt handling. These techniques allow the kernel to quickly respond to events and ensure that critical tasks are completed on time. Hard real-time. Hard real-time refers to a type of computing system that has to complete tasks within a specific and strict time frame, usually in microseconds or milliseconds. This means that the system must respond to certain events or inputs without delay, or else it may cause significant problems. A good example of a hard real-time system is an air traffic control system. If there is a delay in the system's response to an incoming aircraft, or if it doesn't respond at all, it could lead to a potentially catastrophic situation. In simpler terms, hard real-time is like a strict teacher who expects you to complete your work within a specific time frame. If you don't finish your work on time, you'll face consequences like a lower grade or detention. Similarly, a hard real-time system has strict deadlines, and if it doesn't complete its tasks on time, it can have serious consequences. Soft real-time. Soft real-time refers to a type of computing system where tasks need to be completed quickly, but it's okay if they take a little longer than expected. This is in contrast to hard real-time systems, where tasks need to be completed within a specific time frame or the system will fail. To give you an example, imagine you are playing a video game. The game needs to respond quickly to your inputs so that you can control your character in real time. However, if there is a brief delay in the game's response, it's not a big deal and you can still continue playing without any major consequences. This is an example of soft real-time. Task and thread and process. Processes. A process is like a program that is running on your computer. When you open a program, your computer starts a process for that program. Each process has its own memory space and can't access the memory of other processes. Processes are like separate containers that keep different programs running independently from each other. Threads. A thread is like a smaller unit of a process. A process can have multiple threads running at the same time. Each thread has its own instruction pointer that tells it what code to execute next. Threads share the same memory space as their parent process, so they can communicate and access the same data. Threads are like different tasks that a program is doing simultaneously. Tasks. Tasks are often used interchangeably with threads. But they can also refer to individual pieces of work that a program needs to complete. Tasks can be thought of as small units of work that a program can break down into smaller pieces to run more efficiently. Tasks are like individual chores that a program needs to complete to finish its overall goal.